All right. So function notation. We've kind of covered stuff like this. You guys have probably seen it in your Algebra 1 class, but it's this idea of f of x. And I'll kind of refer back to it a little bit. Wow, the objective actually isn't like all along this time. In this lesson, we will learn how to use function notation. Function notation, normally when we think of a function, we're thinking y equals something. For example, the function for how can I put this? The function for a line is y equals mx plus b. But when we're talking about function notation, we're saying f of x equals mx plus b. The reason why this is different is this is saying that we have a function. If you guys ever want to get into computer programming or curious about it, because computer programming goes a lot into video game programming, is we have this function and we're going to call it f. And we're going to say what f is. So in this case, f is mx plus b. So this is the name of our function. F is the name of the function. X is our input. So we kind of learned about this. X is like our independent variable. We don't know what it is, but it's going to change our y. So this is going to give us a number. It's going to output something. So that's what we're talking about here. So if I do something like, what is f of b? Well, I already said f is this function. So f of b would be the same thing as saying m b plus b. I'm literally inputting this where my x was. This was probably a bad example because we already had a b, but you guys get the idea. So if I do like f of 3, I'm saying m times 3 plus b. I'm just inputting it. So let's get into what Edmentum talks about function notation. So again, you guys can always watch the video on your own. So here we're talking about, cool. So we're talking about an input. So they're talking about an input, and then they're going to talk about an action. This action, think of this action as your function itself. This is what's happening. So our input in this case is whatever we order off of this menu. That's our domain. Our function is what we're going to do to it. And then here is our output. So we're going to start with a domain, anything we can order off this menu. Then we're going to do it with our function, which is we're going to cut whatever's on that menu. And then our output is this right here, whatever's happening after that. So that's what they mean by functions. I've also seen the example of it's a machine. You start with raw materials. So you have this X, it goes into this function, and then it pops out a Y. So it goes into here, something happens to it, and it changes. So that's what we're talking about with functions. And then here's an example. They're like, oh, so you have a domain, you have your input. Remember, your domain is always your X values. It goes into a function, it goes into this machine, whatever it is, and it's going to pop something out. This is going to be your output. So in this case, let's say our input is 5. Our function is x squared plus 5. So this machine's doing all kinds of stuff to it. First, it's going to square it. It's going to be 25 plus 5. And we're going to get an output of 30. So 5 squared is 25 plus 5 is 30. So that's all we're doing here. This is how we look at a function. And there's going to be a video. So function relationships. So the relationship, for example, is this idea of someone selling tickets. So someone selling tickets, they earn money. They earn money for all those tickets, but then they have to pay money. So like if I was hiring someone, like if I hired one of you to sell these tickets for me, you guys are collecting all of this money. You guys collected like $600 from me. Um, and the way we got that money was $10 per ticket, right? So it's gonna cost me. Oh, I'm sorry. This was the cost. It cost me $600. Those are my expenses. What I'm putting into it is 10 times however many tickets I sold minus my cost. I'm paying you guys $600. So I better sell a lot of these tickets. Like, you guys are doing a play, I have to sell a lot of these tickets. So if I don't sell any tickets, well, I just lost money because I still have to pay you guys. I'm not going to not pay you. If I only sold one ticket, it's like, well, I lost less money. So this is the idea of functions. It's this relationship that we get. People are buying tickets. However many tickets people buy, that's going to be our input. My output would be how much money I owe if it's negative, or how much money I make, which is our profit. So here we're going to talk about we're going to talk about all of our ranges. So again, like I said, if nobody bought a ticket, because our options are we can't have a negative. People aren't going to, I don't even know what a negative ticket would be, to be honest. Our inputs would be anywhere from zero. So our inputs are going to be zero.
To the Cardi B concert.
It's like, oh no, I lost money by buying this ticket. But zero, one, two, three, four. It's all integers, right? You can't have half of a ticket. Sammy can't be like, I want to buy the ticket, but I only want my head to go. So I'm going to buy half of a ticket. We have to buy an entire ticket. So our rate, so this is our domain. These are all the inputs that can happen. Our outputs, our range are all of our possible outputs. So I already said if nobody buys a ticket, I'm out $600. If one person buys the ticket, I'm only out $590. So this is what's known as our range. These are all of our possible outputs. So the outputs possible outputs, this is known as our range. Our possible inputs is known as our domain. So let's take a look at this. So this says a car is traveling 26 miles per gallon. So we're going to pay 26, every 26 miles, it takes up a gallon. If the distance can be given in the function, what is the input of the function? So in other words, we're saying distance is our output. Anybody want to take a guess of what our input is? What's our input? How far we go is this? What's going to be our input? Anyone want to take a guess?
Is it 26 miles?
It's
26.
It's not 26. That's going to be a number in our function. But that's a good guess. It does involve something with this number. We know miles is our output. So what do you guys think is going to be our input?
Is it G?
G, it's gas. Exactly. Our input is gas. It's 26 times G is going to give us our D. Yeah. So think about it. We put gas into the car. In return, that car is going to take us somewhere. So that's going to be our answer. Our input is G because we're putting gas into this machine and we're going somewhere. Our output is, well, besides carbon emission, our output is we get to travel. So why are they putting like calculus equations on here? They're trying to scare you guys. So now we're going to talk about function notation. So that's this idea that I was talking about before. Our function, this is the name of the function, and this is our input. So for example, that other one, it was d of g. D of g. This doesn't mean multiplication. This means our distance is our output. So that's our output. And our gas is our input. Input. So that's what it means by function notation. So in this case, this person is starting a function f, and the input is x, and the function itself is going to start off with this x squared. We're taking that x and we're squaring it. That's what that function is doing. So now we're going to talk about wages. So this person, this guy Andrew, he's making $4 an hour. So for the first 30 hours, he makes $5 per hour for each hour he works over 30 hours per week. In other words, his wages equal 30 hours plus $5 an hour. So, first 30 hours he works each week. So, in other words, 4 times 30 is how much he makes. But if he works more than that, he's going to also add 5x for every hour over this. So, this is a little weird, right? Because, well, I don't want to multiply by x because I'm working more. So he's making more money. He still makes his $4 an hour, but he gets more money if it's after 30 hours. So I'm going to go ahead and show you. I'm going to write it down and I'm going to explain to you what this means. So in this case, our W equals our wages. Let's just pretend he's not getting this extra $5 an hour over those 30 for right now. So if I just wanted to do how much he gets paid 4 times H. H is our input. So we're doing this. So if I wrote this down in function notation, it'd be W input of H equals 4 times H. But now we are going to talk about this over 30. How do I figure out how many hours are over 30? Well, how many hours, if I work 31 hours, how many hours did I work over 30? Anybody?
1.
How did you figure that out?
If you do 31 minus 30,
Exactly.
it's 1.
Yeah, it sounds really obvious, but when you're writing a function, sometimes it's a little hard to think about that. But yeah, you just subtracted 30. That's exactly right. So what we're going to do here is we're going to add 5 times our hours minus 30. So that's what you do here. That's how this would be your answer to your question. So we subtracted the 30 because that's how many hours they worked over 30. We're not including, if he works 20 hours, that's not going to really help us out that much, right? Like, he's not going to get that extra $5 because he didn't work those extra hours over 30. We'll get into piecewise functions later because technically this is supposed to be a piecewise function. But don't worry about that. I'm just kind of getting ahead of myself. So now we're going to use our answer. So what we're going to do here is we're going to use this idea. And just so you guys can see, I'm not making stuff up. Here's my equation. They simplified it a lot more than what I did. They're just automatically assuming he's working the 30 hours to make it easier on you guys. I'm just going to do this. Oh, wait. Oh my gosh. They really made this complicated for you guys. I'm sorry. he only gets an extra dollar an hour. Ugh. So they want you to do the 120 plus 5 times that. I don't know why they're doing it this way. They usually make it a little different. I guess they're doing it to avoid negative numbers, but this is what they want you to do. I don't like it. I'm not a fan, but they're already assuming that he worked. They're assuming that he already got his $120, basically. We already got that 120. How much extra are we making? That's going to be our function. So, sorry about this, guys. Sometimes Edmentum likes to make things difficult. But anyways, so now we're gonna use this function here. Luckily, I looked at it. So the thing that we're gonna do here is we're gonna do this 12, or I'm sorry, 120 plus 5 times our hours. So our hours are going to be 32 minus 30. We're gonna get 2. So he made an extra $10, right? So we're going to do that 120 plus our $10. So what did he get out of it? Well, what he got out of it was $130. I think they're going to want you to ask for the function and then they're going to ask for the answer. Yep, they're asking for the function. Real life, how would we do this domain and range, blah, blah, blah. So they just want you to write in this part. Our function, which I don't know why they're doing F. Honestly, they told us our function was W for wages. So our function is 32, W of 32 equals 120 plus 5 times 32 minus 30. This is how you would write it down for all of them. The only difference is what our input is. If our input is 36, we're going to change this 32 to 36. And we're going to change this 32 to 36. And that's how we can keep applying this function to any number they give us. So you guys can just, what I do, because I'm lazy, I just copy this. If you guys don't like using your touchpad, what you can do is shift, use your arrow that highlights it, Control C, Control V, and I'm going to change this to 38 now. Basically, what I'm doing here is essentially what I'm doing. I'm just changing my H's. So that's how it works in programming language and anything. All I'm doing is I'm changing these H's and it makes it really easy because if you're copy and pasting, you know exactly what you need to change. So now explain how real life situation is a function with worker input. I'm going to do kind of the same thing, but I'm going to do it a lot easier than that. Let's say I make, I don't know why they're doing that $4 an hour. In the real world, minimum wage, if it's not already, I know it's going to increase up to $15 an hour. So $15 an hour. So what's my input? My input are the hours I work, right? And my output is money, dollars, right? So that's how I'm going to do it. So my domain, my input, I said were the hours I work. My output was, in this case, our money. And what's my domain? Well, my domain is 0, 0, like my age can be less than or equal to that. So H can be less than or equal to 0 because if I don't work, I just don't get money. That's my input. My output can be anywhere. Usually minimum wage has to be, or usually you only work like 4 hours and 40 hours in a week, right? So miles per gallon. Oh, that was from before. So this is my input. My domain is 0 to 40. What's my range? Well, my range is what I get. Oops, that was supposed to be in blue. Why wasn't it blue? Blue. Oh, I already did blue. Uh, range. My range is I'm going to put the input and get my outputs, right? So my range would be anywhere from I'm going to do green, $0. Because guess what? 15 times H. This is my function, by the way. I forgot to write that down. W, or I guess dollars, because I'm doing dollars. I'm doing money. Dollars times H equals that. So if I plug in 0 for my very smallest domain, the least I can get is $0. If I don't work, I don't make money. So this alligator is looking for the money and it's saying like, okay, this has to be bigger than or less than 0. But the dollars can be smaller than or greater than, smaller than or equal to times 40. And in this case, I'm going to be 40. I'm going to use my calculator. Later.
Wait, so the alligator's looking for the money?
The alligator in this case is looking for the bigger thing. So yeah, I could look for the money. In this case, it's looking for whatever's bigger. It's looking for more money.
More
Well,
like alligangster. Am I right?
yeah, I guess so. It's looking for that money.
I'm just not gonna say any more stupid jokes. Stop.
Says the guy who speed runs Minecraft.
Hey, it's difficult.
So in this case, this alligator is looking for the most amount of money. So, well, I could get more money like by not working, or maybe if I even work $1, 1 hour. And the most amount of money is going to be the 600 because I can't work more than 40 hours. So what you can do here, you can just explain a real life world. You guys can use my example. Just make sure to type it out and make sure you're labeling everything. What is your domain? So my domain was anywhere. My domain in my example, at least. My domain was how many hours I worked. What's my range? My range was how much money I got out of it. That makes sense. So you're just going to type that in. How does your function notation in this example work with standard notation? So standard notation is what we're used to. Y equals 15x. Our function notation is W H. This is our output. What's our input? Equals 15 times H. That's all I'm doing for my real world example. And then you just kind of write about like how hard you found this, how easy you found this. I would honestly probably say a 3 because I don't like how Admentum did this. What they should have done was something like he gets $2 extra for every hour. That makes it easier because then you can do something like, what was it? 4 times x plus 5 times, or I'm sorry, 5. $2 extra. He gets $2 extra. So then we're going to add that 5 minus 30. I think that's how Admentum should have done it. Even if they would have done, he gets $1 extra. Another way to write this function is like this, but I don't know. They decided to make this difficult. So that's one thing I would write in the self evaluation. How did you do? I got confused. Nobody's judging you, Savvy. Like, good job of contributing to the conversation. All right. So let's kind of look over here. So evaluating a function. By evaluating a function, they're just like plug it in. Plug it in, see what we get. Then, in order to find the range, we plug in the smallest number. We're going to plug in the smallest number we get, and then we're going to plug in the biggest number. That's going to give us our range. So I kind of already did that when I was talking about the money. The minimum I can work is 0 hours. The maximum I can do is the 40 hours. So I would plug in the 40. So I plug in the 40. I realize I'm like using hand gestures and stuff, and you guys are probably just looking at my screen. I can plug in this 40 for my max, and then I can figure out what happens when it goes into my function. And that's going to give me my maximum output. So let's go into here. They're going to give us a video. Again, you can watch that on your own. Well, this gave me the answer already. Well, let's look at what they did. I don't like how the teacher's edition gives you the answer right away. What's happening here is first, this is our function. Our function's called f. Our input is x. Then we're going to plug in this 4. I don't like how Admentum doesn't show that you should put parentheses whenever you're plugging something in, just to make it a little more exact. The reason being is if they give you a negative 4, for example, when you do this, you would get this 16. But let's say I forgot to put that parentheses. I could have thought this was negative 16. I didn't know that there were parentheses, so I assumed it just wanted me to square the 4 and then put the negative. So it's always safer to put parentheses. But if you plug it in, you can see how they did their steps right here. Moving on. Let me know if I'm going too fast, guys. I'm just trying to make sure we have enough time to go over the unit activity a little bit. But if you guys need me to go a little slower on this, let me know. All right, so we're going to go back to the function that they gave us. So the function they gave us was our profit equals ticket sales minus our costs. So they're going to ask us if the number of ticket sales is greater than 60, then we make a profit. And that's true because think about it. We want to make a profit, so we want to at least reach 0. We want our costs to equal our revenue. Revenue in the business world is known as money coming in, money we're getting. So we want our revenue to equal our cost. That's known as our break-even point. Where these two lines meet, that's known as the break-even point. All right. Anything bigger than that, so we found that if we plugged in 60, we got 0. So anything bigger than that, we make a profit. For example, if we sell 61 tickets, we're making $10 whole of profit. All right, moving on. So now we're talking about the length of a function. So this person, so Jim and their dad, they have a flower bed. So this flower bed, and the flower bed, the total feet of landscaping timber. So they're using 35 feet of timber. They want to use all of it. However, they are not sure the length, so they have no idea what their length and width are. Okay, so if they're not sure what their length and width are, but in this activity, we're going to write a function where our perimeter equals 2 L's. That makes sense because we're adding 2 L's and W. So our perimeter equals this. So in other words, we want to we want to put this 35 feet going around the bed. And this has to equal 2L plus 2W. So let's look at what questions they want us to do. They want us to do something where our input, our W is our input. So they want L of W. So we need to figure out, we need to solve for L in this case. So use function notation to write it in terms of length and width. So what we're going to do here, I'm going to show you guys how to do it in here just so you guys are able to show all of your work. So first things first, I'm going to say that 35 equals 2L plus 2W. The next step I'm going to do, I want to solve for my L. So I'm going to do 35 minus 2W. I'm assuming you guys already know. I'll write it over here. I'm assuming you guys already understand the idea that we're going to subtract the 2W. I'm just going straight into it. So I'm kind of skipping these steps here. I'm just kind of showing the work, how it would show on your guys' end. So this is going to equal 2L. So this is going to equal our 2L. So in other words, our L equals, I'm going to do a big fraction because I'm going to divide by 2. So I'm dividing by 2. What am I dividing by 2? My 2W, I'm sorry, 35 minus 2W. I'm subtracting my 35 minus 2W. So if I wanted to write this in function notation, I would write it as L of W equals, I'm just going to copy this, paste it in there, and that's going to be my function notation. They might simplify it a little bit more. I think they will. Oh, they did it like very different. They're multiplying it by 0.5 instead of dividing by 2. I like to divide it by 2 personally. I don't like this whole like, why are we multiplying it by a decimal? Why are you doing it as a function? Why don't you just put it as L? Call your function L, function for length, you know? I think they're going a little extra on it. So now what I'm going to do is, now they're telling me make this function assuming that the width is 15. So now what I'm going to do here is I'm going to go into my function notation. I'm going to go L of 15 equals 35. Oops, let me make this a fraction first. 35 minus 215 divided by 2. Cool. I go to the next step. Again, I'm lazy, so I'm just going to copy this, select it. I control C. Now I'm going to control V. But I'm going to do my multiplication step. So 2 times 15 is 30. And I'm going to divide that out afterwards. So again, me being lazy, I'm just going to copy this. So select it, Control C, Control V, 35 minus 30, 5. And I can leave this as my answer, guys. So if you guys want to leave it as a fraction, leave it as a fraction. That's fine. I have a feeling Admentum's going to want you to do it as 2.5, which is 5 divided by 2. I don't care. Yep, they left it as 2.5, 2.5 feet. I kind of get what they're saying. They're like, you know that it's 2.5 feet instead of what the heck is 5 divided by 2 feet. So that does kind of make it easier. They decide to decrease it. So Jim decide to decrease the width of flower bed from 15. What happens to the length? So think of it this way. If this is related, right? So if we decide to do this 35 minus 2 and our W becomes even smaller, because they have to add up to 35, if we decrease our W, that means we're going to increase our length. So because we want this perimeter to be the same, if we decrease this, we're going to have to make it longer so it's still equal to 35. So this is just talking about the relationship basically. So if we decrease our width, we would have to increase our length. That's all we're doing. So they're saying, what is the domain of this? Can you explain your answer? So I'm going to say my domain is going to be, this is a little tricky to explain. Um, I'm just going to say, I'm going to pretend that this flower bed doesn't have any length to it. It's all width. We're going to pretend it's all width. So if it's all width, we have 2W, 2W. So, or I'm sorry, 2W. We have W plus W, right? Which is 2W. We're basically pretending we have no length. We're going to do this 35 equals, what is this? 35 equals 2L plus 2W. Sorry, I had like a little brain fart there for a second. If we look at the original one, we're going to pretend that we don't have any length, right? So that means our W has to be less than whatever half of 35 is. I want to say that's half of 30 is 15, half of 5 is 2.5, 17 and a half. It has to be smaller than 7.5, but it has to be bigger than 0, right? We can't have 0 length, right? So when I'm typing in my answer, is this making sense, guys? I know this is a little complicated. Do you understand why it's 17 and a half? Why I kind of canceled out the L? Yes, no, maybe? Okay, cool. Yeah, it's this idea that we don't have a length. We're not going to say equal to because we have to have a length. That doesn't make any sense if we don't have a length. So what we're going to do here is we're going to say the width has to be greater than 0, but less than 17.5. This is because we must have a width for area. And if we pretend, we're just going to pretend to not have a length, the width would have been 17.5. So since we must have a length and we must have a width, if we pretend we don't have a length, our width would have to be 17.5. So we have to have a number smaller than 17.5. This is how we figure out our domain. This one, if you had trouble understanding how I figured out the domain and length, you might want to write that down. It is a challenging topic to write down. You might even be like, I didn't understand it at first, but when he explained it a little bit more, it made more sense. So definitely write that in on your self-evaluation. So now we're gonna talk. Why does this keep giving me out answers? We're gonna pretend that now we know what our output is, but we don't know what our input is. So what is the input of this function? So instead of writing f of x, we're gonna write f of x equals 11. So if f of x equals 11, we're gonna substitute this right here. So we're gonna say 11 equals 2x plus 5. If we subtract the 5 from both sides, we get 6 equals 2x. If we divide by 2, x equals 3, which I believe was the answer before I hit it. What? Oh, 3. Why'd I put 2? Why'd you guys let me click 2? Try again. 3. I clicked the wrong thing. There we go. And it shows us the work right here. They showed us doing it backwards. They substituted it in, multiplied it, and we still get 11. So they kind of backwards worked it out. So again, guys, watch your summary. I do recommend it for when you're doing your mastery tests. It helps out a lot. Let me go over so again, this is going to be due tomorrow at midnight. These are going to be due over the weekend. As someone said before, you can work on it ahead of time. So let me go into this. Okay, so it is this. I'm going to stop the recording now because if I don't, I'm going to keep recording